All right, so we're starting chapter 7, and chapter 7 is talking about something called systems of equations. And then towards the second half of chapter 7, we're going to get to systems of inequalities. So it's basically working with two equations at one time. So we know how to solve one equation and get the solution. So now we're going to talk about solving two equations at the same time and what the solution of both equations is. So we're going to start off with some vocab. And the first section that we're going to be talking about is 7.1. It's graphing. So it's solving systems using the graphing method. So there are three different methods we're going to talk about, and this is the first method. So we're going to talk about graphing today. So here we go. Some vocab. Two or more linear equations together. So again, like I said, when we have, we're talking about several equations at one time. We're not just talking one equation. But two or more. So we could have three, you could have four, you could have five, but what you'll see is we're only really going to work with two. So when you have two or more linear equations together, it forms a system of linear equations. Any ordered pair that makes all of the equations in a system true is a solution of the system of linear equations. So any ordered pair that makes all equations true. So that one ordered pair has to work for both equations for it to be counted as a solution. Okay, so we'll talk about what that means when it looks like when we're graphing. A system of linear equations has blank when the graphs of the equations are parallel. Okay, so let's back up a step. I apologize for my talk. Let's back up a step. A solution that is an ordered pair that makes all equations true. So we're talking like when we're talking about graphing, we're talking about lines that are intersecting, lines that are parallel, and then lines that are going to be the same, okay? And when we're talking about solutions, the solution is the intersection, and I want you to make a note of that here on the side. Solution is the intersection. So it's where your lines intersect one another. Okay, so if we're talking about parallel lines right down here, do parallel lines ever intersect? The answer is no. So your answer is going to be no solution. When the lines are parallel, they don't intersect one another. So there won't be a solution for those two equations. Okay? A system of linear equations has blank when the graphs are the same line. So if it's the same line on top of one another, like this, are they going to have one solution? Are they going to have one intersecting point? No. Are they going to never intersect, meaning they're going to have no solution? No, it's something called infinitely many, meaning infinitely many solutions. You'll see it as IMS a lot. If it's the same line and they're on top of each other, the question is how many times are they intersecting if they are on top of each other? And if they're on top of each other, they're intersecting the entire time, which is infinitely many solutions, which we also call IMS. So let's kind of talk about this again. Intersecting lines, how many solutions? Okay, so we're going to go through and determine how many solutions each of these have. How many solutions does this system have? Well, where do they intersect? They intersect at one point, meaning they have one solution. Right? Parallel lines, they never intersect one another. They don't have a solution, so it's no solution. Right? And then coinciding lines, meaning the same line. So it's the same line on top of it. It's infinitely many, or IMS, because they're on top of each other and they intersect every single spot on the line. Okay? So let's get into graphing. Let's talk about what does this look like, how do we graph, and how do we write our solution. So first, I'm going to color code. So I'm going to use green and like a blue color, and then I'm going to go ahead and circle my intersection point and write my intersection with my pink pen. But I like to label. So if you're just using a pencil or a pen, I want you to label your equations so that way it's easy to tell what set of slope and y-intercept goes with what equation. So it's easy for you to pick out and see. So for my first equation, we have y equals x minus 2. What is the slope? So what is the number in front of x? It is an invisible number, so it's going to be 1. And again, if it helps to make it a fraction, go ahead and make your slope a fraction. So put it over 1. The y-intercept is going to be negative 2. Okay. Now before I graph, I'm going to go ahead and write the next equation as well. So I'm going to go ahead and label this number 2. And then I'm going to label this number 2. All right, and then I want to pick out my slope and my y-intercept. My slope is negative 1. I'm going to go ahead and make it a fraction, put it over 1 right away, so that way it's easy to graph. My y-intercept is 10. All right, and now I'm going to go back to, now I'm going to graph. So I'm going to go back to my first step, and I'm going to put it on my graph. All right, so we have a y-intercept of negative 2 and a slope of 1 over 1. So I'm going to go on my y-axis, I'm going to go down 2, put my point. Rise 1, run 1. So I'm going to go up 1 over 1. So I'm going to go up 1 over 1. And I want to remind you, put as many points on your graph as possible. And this is why I always say put as many points as you possibly can on your graph. So that way we have an accurate graph. And this is when it comes into play. This is why it's important, because our two lines are going to intersect. We hope at one of these points, and we don't know which one. So if we're not careful and specific with our line, then we don't have an accurate point as to where they're going to intersect. Okay, so I drew my line, I put all my points on. I'm going to draw my line, and don't forget your arrows at the end. Right, and then I'm going to go ahead and graph my second line. So we have a y-intercept of 10 and a slope of negative 1 over 1. So slope of y-intercept of 10. 1, 2, 4, 5, 6, 7, 8, 9, 10. Okay, so it's up there. And then we're going to go down 1 over 1. So down 1, right 1. Down 1, right 1. And we're going to follow that pattern again and put as many points on our graph as possible. And you should see that your lines are going to overlap and they're going to intersect. Okay, and then you draw your line, and don't forget your arrows at the end. All right, and then I'm going to go through and I'm going to just circle this to kind of make it obvious as to where they're intersecting. So my lines intersect. Yay, that's awesome. That's what we want. So now our solution, our answer to this entire thing is, where do our lines intersect? At what coordinate point? So at what coordinate point? I'm going to draw myself a line down here for my solution, for my answer. What coordinate point is this where they intersect? 1, 2, 3, 4, 5, 6. 6, comma, 1, 2, 3, 4. So 6, comma, 4 is my intersection point, meaning that's the point that works for both equations. It makes both equations true at the same time. Okay, so again, it's our intersection point. All right, so let's do another example. Let's keep going. All right, I'm going to continue with my colors. Now, example 2. This one's written a little bit differently. I'm going to pull example 1 back just so we can look at it. All right. And look at the way these equations are written versus how these equations are written. These equations are written in slope-intercept form, so it's easy to pick out our slope and our y-intercept right away. These are not written in slope-intercept form. So first we got to do a little work before we can actually identify our slope and y-intercept and graph. So what I'm going to do, I'm going to work each equation, and I want to solve for y. I want to get y by itself. So I labeled my equations. All right, I'm going to work with equation 1 over here, and then I'm going to work with equation 2 over there. So I'm going to rewrite the equation, negative 2x plus 4y equals 12. Oh, for y equals 12. Now, we need to solve this equation for y, so we need to get y by itself. I'm going to draw my line. I need to get rid of my 2x first, my negative 2x. I'm going to add 2x on both sides, so plus 2x plus 2x. I have 4y equals, I can't combine them because the 12 does not have an x. So I get 2x plus 12. Is my y by itself? No, I need to get rid of that 4. So I'm going to divide by 4. Divide by 4, you get y equals 2x divided by 4 is going to be 1/2 x. 12 divided by 4 is 3, so plus 3. This is my new first equation. So I'm going to go ahead and box that and label it 1. Okay, we're going to repeat the same process here for the second equation. So we get x plus 4y equals -12. All right, so same idea. We want to get the y by itself. I'm going to go ahead and draw my line. Get rid of the x first. I'm going to subtract x on both sides. You get 4y equals -x minus 12, because this 12 is negative. Y is not by itself, so I have to divide by 4 on both sides. So I get y equals -x divided by 4 is -1/4 x. And then -12 divided by 4 is -3. And I'm going to go ahead and box this and label that equation 2. So now I can pick up my colored pens and I can go ahead and identify my slope, y-intercept for both equations, and graph. So here we go. Slope, y-intercept for first equation. We got 1/2 for our slope, 3 for our y-intercept. I'm going to go ahead and pick up my second pen, number 2. Slope, -1/4, y-intercept, -3. So I'm going to go ahead and graph them on my graph now. So I'm going to start with my first equation. I have a y-intercept of 3, so I'm going to go up 3, 1, 2, 3, put my point. And I have a slope of 1/2, meaning rise 1, run 2, rise 1, run 2. And again, as many points as you can possibly fit on your graph, because you don't know where it's intersecting. Okay, you need to put as many points, and you need to take your time and be neat and organized with this process, because you're not going to have an accurate result if you don't. So draw your line. Time to graph the second equation. So I've got a y-intercept of -3, 1, 2, 3. A slope of -1/4, so down 1 over 4. Down 1 over 4. Down 1 over 4, and then back the other direction. So I'm going to go up 1, left 4, up 1, left 4. And 9 times out of 10, it should intersect at a nice point on your graph. It shouldn't be something that you have to estimate or something that is kind of in the middle of the grid. It should be a nice, easy point. So what is our coordinate point of intersection? We've got 1, 2, 3, 4, 5, 6, 7, 8. So -8, -1. And that's our solution. Okay, because that's where the graph is intersecting. All right, 2 more examples. What I want you to do, pause the video right now. I want you to give these a try on your own. And then after you give them a try, continue the video and hit play and double check your work with mine. Okay? All right, so hopefully you did pause the video, so you should be checking your work with mine. Example 3, they're already in slope-intercept form for you, so it's easy to pick out your slope and y-intercept right away. So equation 1. Here we go. Slope is going to be 3 over 1, or just 3, whatever works best for you. Y-intercept is 2. We've got our second equation. Again, in slope-intercept form, easy to pick it out. We've got 3 over 1 and -4. All right, so graphing the first equation. Here we go. Y-intercept of 2, so I go up 2. And then a slope of 3, so rise 3, run 1. Rise 3, run 1. Putting as many points as I can fit. And that one kind of goes off, so. All right, and here's the second one. So we have a y-intercept of -4, so 1, 2, 3, 4, slope of 3. So again, rise 3, run 1. And you should have something that looks like this. What do you notice about these 2 lines? They don't what? There's no intersection. So what's the solution? What's the answer? Remember from the front page of the notes. What happens when they're parallel and they don't intersect? What's the solution? There is none. There is no solution. So your answer is going to be no solution. Okay, so now here we go. Last example. One of the equations is given to us in slope-intercept form, and the other one is not. So I do need to solve this first equation for y and get y by itself, so I can figure out what the slope and the y-intercept are. So 3x plus 4y equals 12. I need to get y by itself, so draw my line. Move the 3x over by subtracting, so I get negative 3x plus 12. Y is still not by itself, so I have to divide by 4. So I get y equals negative 3x divided by 4 is negative 3/4 x. 12 divided by 4 is 3. So this is my new first equation. So I'm going to write my slope and y-intercept out. I have a slope of negative 3/4, and I have a y-intercept of 3. My second equation is still up here at the top. It's in slope-intercept form, so I can pick out my slope and y-intercept. And I've got negative 3/4 and 3. All right, so let's graph. Here we go. Y-intercept of 3. 1, 2, 3. Slope of negative 3/4. So I go down 3/4, down 3/4, down 3/4, and then up the opposite direction. So 1, 2, 3, 1, 2, 3. 4, 1, 2, 3, 1, 2, 3, 4, and then last one. All right. All right, so let's graph the second equation. Here we go. We've got a y-intercept of 3, slope of negative 3/4, up 3. Oh, what do you notice? It's the same line, right? So if it's the same line and they're on top of each other, what is this solution going to be? Infinitely many. They're on top of each other, which means they are intersecting infinitely many times, right? They're intersecting at every single point on this line. So the answer is going to be IMS, or infinitely many solutions.